Hi, this is Alex from devstories.eu. Apache Cassandra with Python, Episode 2 of 12. Naive data hashing completely breaks down the moment you add a new server to your database cluster. When the number of servers changes, almost every piece of data has to move to a new location. The solution to this scaling chaos is consistent hashing and the ring. A standard way to distribute data across multiple servers is modulo hashing. If you have 8 nodes, you take a partition key like a user ID, hash it, and divide the result by 8. The remainder tells you which node gets the user profile. This works perfectly until your storage fills up and you plug in a 9th node. Now you divide by 9. The remainders change. Almost every user profile in your system suddenly belongs on a different server, causing a massive, cluster-crushing storm of data movement. Cassandra avoids this entirely. It uses consistent hashing to predictably distribute data across the cluster without relying on any central coordinator. Instead of a simple modulo calculation, Cassandra maps both the data and the nodes to a fixed continuous circular space called the token ring. By default, Cassandra uses a hash function that generates a massive range of possible numbers. The lowest possible hash value connects directly back to the highest, forming a closed circle. Every physical node in the cluster is assigned a specific number or token somewhere on this ring. When you insert a user profile, Cassandra hashes the user ID to produce a token. To find out which node owns this profile, the system locates the data token on the ring and moves clockwise. The first node it encounters is the owner. Think back to our 8-node cluster. If we add a 9th physical node, it gets assigned a single new token on the ring, landing between 2 existing nodes. Because data ownership is determined by walking clockwise, this new 9th node only takes over a specific slice of data from its immediate clockwise neighbor. The other 7 nodes do nothing. Their data remains completely untouched. Here is the key insight. Assigning exactly one token to one physical node creates operational problems. It's difficult to balance the data perfectly, and when you add a new node, only one neighboring server is responsible for handing over the data. That single neighbor gets hammered under heavy load. To fix this, Cassandra uses virtual nodes, or vnodes. Instead of giving a physical server one massive contiguous slice of the ring, vnodes chop the ring into many smaller ranges. A single physical node is assigned hundreds of different tokens distributed randomly around the ring. When you add that 9th physical node using vnodes, it claims many small slices of the ring from all the existing servers at once. Now, instead of one neighbor doing all the heavy lifting, the entire cluster evenly shares the work of streaming data to the new machine. Consistent hashing and virtual nodes decouple data placement from the raw number of physical servers, allowing a cluster to scale up smoothly and operate predictably without any central master dictating where data should go. That is your lot for this one. Catch you next time.